Excited? Tea break is done. And the idea behind what we are going to talk about, everything, is not just knowledge, or it is not just like some piece of information. So all of us have been working into the Web3, crypto, or the decentralized space, but it is more of like I'll be exploring you guys through like how it comes from and what is the history beyond decentralization and all of it. So let us quickly get started. A quick background about me. I lead DevRel and ecosystem at Koi, and apart from that, I'm also a core contributor at OG Club. And then previously I've managed communities for Code Asylums, Communal, and a lot of others. I've built communities from scratch to multiple thousands, help products scale on users and things, and that's much about it. So the question is, why are we all here for? So the entire idea comes down to nobody likes corrupted governments, or nobody likes getting the content generated by us getting hidden behind paywalls or something like that. So we are all here to get a more user generated and user owned internet. How many of you guys agree on to that, like along with me? Can I get your guys hands up on how many of you guys want an internet that's owned by the users? Right, that's all what Web3 is about. So let us quickly roll back to a couple of things. How do we make the knowledge like global, accessible, and more immutable? So there are a lot of rolling factors around it, and there are a lot of bigger bodies that govern all of this information. So we will be quickly talking about like how it has been coming through and who owns it, and like all of those into detail. So coming up next, decentralization is not a new idea, first of all. So rolling back, okay. So decentralization is not a new idea, first of all. There were early currency systems rolling back to 1000 BC. Then there were artist collectives 2000 BC. Then, so you might have seen that there's a picture of like dots connected via lines that you might see in every Web3 and decentralization presentation, right? So Rand Institute commits that they came up with the first idea. They coined the term decentralization in 1978. So that's all when it started. Then Bitcoin came into 2008, and that's when that was the entire time when US government fucked up the entire cash system and the cash flow. So nobody wanted that. So they came up with the decentralized currency system. I hope everyone loves Bitcoin here. How many of you guys have read the Bitcoin white paper? Only a couple of folks. The rest of you guys should read the Bitcoin white paper, guys. It's crazy. And so then in 2015, Ethereum came up when Vitalik, as the genius he is, so he came up with apart from just currencies, we can use the same infrastructure for information and data. So that's when Ethereum came up. And then now we are building Koi. Okay, sorry. So now we are building Koi, and so okay, this is nowhere that I'm putting myself or Koi around any of these things, Bitcoin or Ethereum, but I need to do some sort of things because otherwise my company won't pay for my trip. Anyways, these guys are doing it, but still. So coming up next. So these are rice stones, and these come up rolling down from Indonesia. So as I already told you, you guys should always know the history from where decentralization comes. And so all of these big crazy stones, and back then what used to happen, like people used to go from one island to another island by a boat, and they used to find out these big rocks. They used to put out that hole, tie it to their raft, bring it back to their homes, and then they used to put it in front of their houses, which was a presentation of their power and everything. The idea was that this is decentralized. Why? Because 5 of you guys can go and pick up those stones, right? But 5 of you guys cannot print currency at your home today. So it is not decentralized now, but it was back then. Coming up next. So these were tally sticks that were used in England, and the way this used to work was, this was used for mostly taxation things, and the way this used to work was the tax person came and they used to break it down into 2 pieces and match their imprints And this used to work perfectly fine until the Tower of London broke into fire and all of these were burned. So we need immutability. So that is one of the prime concerns. Coming up next, guys, I don't know why my slides are switching again and again. So yeah, so until like these got burned. And also again the second point is we need multiple copies of data, not just two. So these were like not so effective. Coming up next, the art colony. So you guys might have seen like the NFTs and all the people building up NFTs. Some are shit on NFTs or anything. So NFTs have the money right now. But these were the things where they used to run the entire colony on pieces of art, and most of the art pieces from these art colonies are now placed in North American museums or somewhere like that. So they used to run their education systems or like other infrastructures for their colonies based on these. So this is entirely about, I'm just trying to establish an idea of how decentralization used to work previously, and we'll be exploring a couple of things. So this is the image that I was talking about. How many of you guys have seen this before? If you have not seen this, you do not belong to the Web3 herd, to be honest. So this is the centralized thing again, and then this is decentralized, and this one is distributed. Now talking to the point, we talk about decentralization every day, but decentralization is not the end point that we want. What we want is this distributed systems. Now these distributed systems, so while we reach to the distributed systems, these decentralization is a way to it. This is how we get there. So once we have built out this infrastructure, it is going to help us to reach to that level of infra that we are trying to build. Talking about the things, the vision for a world computer wherein you build the internet, you host the applications that you are running, your friends are running from your local devices. This is the entire idea. Previously there used to be Swarm, Whisper and all of that, and which is now mostly dead. And Ethereum, which used to be like, which is again, right now even it is there, for transaction sequencing and logic. Coming up next, while I was making my slides, I found this thing on Reddit. So have Swan and Whisper been abandoned? So I thought it would be good to show you guys as well. Coming up next, so what did we get like from all of this getting up as a context? We have these like couple of transaction sequencing and logic things. Then we have a lot of storage factors that are governing the storage space, RV, IPFS and like all of that. There are a lot of names into it. But now the entire idea is, how do we connect you guys to these guys providing storage solutions or anything like whatever you are transacting or anything. So the entire idea is you should be owning a part of it to get the ownership of the internet. So that's where we come in, which is the communications layer node. Coming up next. So this is what I've been all trying to put it along, which is task nodes. So let me come to what task nodes are. Task nodes basically are small piece of softwares that you can install onto your devices, and you can rent out the idle compute on your device for someone to use, and you earn koi tokens with exchange for it. Coming up next. So now again, so for all my techie friends out there, how many of you guys understand tech and like a little bit of app infra and everything? A couple of people? Okay. So this is for you guys. So we have like these fully deterministic machines. These are like very hard tested and programmed. So they have like very limited things that you can change with them. But coming up to fully verifiable compute, this was again a very good invention in itself. But so a couple of examples are Luke and Move. But the disadvantage was what they used to do. They used to verify output on every single line, which made it very compute intensive. When it was compute intensive, what used to be that it was requiring so much heavy intense compute that what climate change we are seeing as of now, it would have been achieved like 10 years back. And then so it is not like scalable in terms of energy compute. We have to be aware about the change in the planet, and the we have to make sure the entire thing works together, because it could not be like a bunch of nerds like me or you guys coming up together to build an application that fucks up the entire earth. Because, so Web3 has so much money that you build an application and you have like, so much budget to run it. You pay like, X and X and X amount of money to AWS to run your applications and everything. But like, it does not work that way. You have to take care of a lot of other things along the sides. So coming up next, introducing CARP. So CARP is our Computation, Attention and Reputation Protocol. How this works is, so sorry guys, I sweat a lot and this has been a huge trouble like, while I'm doing conferencing. So, yeah. So now like, how we have been building up things, how tasks work actually is that we have been building reputation systems wherein people who are running nodes or anything of that sort, right? They establish reputation over a period of time in the global network of nodes. So the entire idea is reducing long-term audits. What does that mean? Let us understand. So what happens is when your reputation rises for doing good work in the ecosystem, people audit you less. Very real-time example. बहुत ही easy words में अगर इसको हम समझें, अगर if you have worked like lot of work into the community, you have built like crazy applications. So अगर if you are interviewing a company and they have like 10 rounds, you might get selected in 3. So dude, that is what reputation is all about. So and then reduce duplication of work, because reduced duplication of work. So when it is getting audited less and working more of on a trust factor, then the compute is less and like all of those factors come down to like scaling down a lot of other things that matter, that do matter, because it is a lot about adoption. In the end of the day, you cannot be like building shit and expecting people to come and use it. It is all about adoption. And there is one very famous line that I got to hear from someone in between of a conversation, but it is again in Hindi. So I'll tell it to you guys. So it goes like कि अगर आप एक एप्लीकेशन बना रहे हो, एक प्रोडक्ट बना रहे हो, उसको फाउंडर, मार्केटर या डेवलपर बनने की जगह आप लेट अस से कोई भी एक इंसान है जो कि एक चैट का एप्लीकेशन बना रहा है ऑन एनी ब्लॉकचेन, आप अपने आप से एक सवाल पूछो, अगर आपको एक एप्लीकेशन दिया जाए तो क्या आप व्हाट्सएप, ट्विटर, टेलीग्राम ये सब छोड़ के उसको यूज़ करोगे? या आप अगर साइन अप भी कर लिए तो क्या आप उसको 1 महीने यूज़ करोगे? That is what adoption is all about. You have to build it so crazy that people do not find out like कि उन्होंने कब transition कर लिया. So that is all about it. Shout out to Social 3. You guys might be aware about them, right? So they have been doing real good work, and so like they have built like decentralized LinkedIn and everything, and now they are transitioning. People are posting jobs, people are getting jobs. So cheers. Coming up next. So what are tasks? This is like I'll just go through very fast on these because these are very developer centric things, and if anyone wants to chat about it, I'm more open for a conversation after this. So tasks just contain 2 files, an executable and an audit file. Executable defines what needs to be done, audit defines how it needs to be checked, and then nodes with a reputation and like collateral. So they stake their collateral to do a certain task, and how is this like this all of this works. And getting this real quick, so you write your task, you get it registered on IPFS, which is the storage layer. It goes on to our K2 settlement layer, where people stake some kind of a collateral, which is ideally koi tokens, but we are also introducing some kind of stable coins and other things so that it becomes more rewarding for the end user. And then like this is the entire audit process and all of that, how it works, because a lot of written text is also not very clear on this pixelated boards, but anyways. So coming up next, again for my dev brothers, so this is the execution environment where you have like the beauty of JavaScript, that you can start building with code, that like you can build your entire web app, which is again decentralized application in JavaScript. And the craziest thing, can you think of what we have done? It's written second last from the bottom. If you want to have a read, I will stress a lot onto it, because let me give you a very basic example. So this is secret injection by node operators. Let me give you a very basic example. So let us say there's a platform that gives you 300 API hits in a single day on a free account. but you have to pay $500 to get onto their enterprise tier, or get more API credits and everything. So what you can do is, you can register a task on Koi and get your task rolling to 10,000 node operators. They go and create an account on their website, get their secret API keys, they inject it into their node, and then you can utilize it for that scale. So what are the numbers now? It is 500 API credits per person, and now you have 10,000 people. So just calculate the numbers, how much you are getting it, and that too at a very negligible cost, So I'll be coming to real-time examples of how our developers have actually scared a couple of agencies, and they are now fickling with lawyers and everything. I actually have scanned news articles that got published because our developers fucked up their entire system. So coming up next, this is gradual consensus. Again, so the entire process that I explained you in a very detailed manner, this is how it gets repeated. There is a round of epochs that happens every 12 hours, 10 hours or something like that. But this is completely customizable and in the hands of the developer who wants to write that task and define it, so this is customizable up to them. They can reduce the time, increase the time as per the task and as per the requirement. And so there are multiple rounds and slots of epochs that are happening, and all of this takes down to getting faster compute, faster availability, and any kind of achievements that they want to do with the network. And a lot of people ask me whether you are a layer 0, layer 1, layer 2. You are not. You are layer N. Now you would be like, what the fuck is layer N? I've never heard of it. How many of you guys are like, what is layer N? Guys, hands up, please. How many of you guys are like, what is layer N? Only 3 people. Okay, I presume that only you guys are hearing me. Okay, so layer N is something that there is a set of nodes. So I'm just taking an example for web scraping for it now. So there are n number of nodes that do the scraping for you. Then they bundle up all of that data into a REST API, send it to another one, which does all the indexing process. Then there are n number of nodes that create Merkle trees and subgraphs for all of that information. They again bundle that information and put it into REST APIs and give it to another set of nodes for searching. So the idea behind this is breaking simple tasks into smaller subtasks, help you build more trustless applications, because that is what Web3 is all about. So if you guys dig more deeper into it, you'll get to understand what I'm trying to say here. And again, happy to open more conversations post this. So the cookbook, talking about quick things that people have been doing along with Koi. So proofs, you can generate various proofs random numbers, attention tracking. And so we have this attention tracking where people earn Koi tokens based on the amount of attention that they are getting from the network or anyone. And then they can use those tokens to pay for their hosting. How cool is it, isn't it? So coming up next, for an example, so if there is a guy who's building social media, they built a social media, you are the end user. You are running a node for the application that you are using, not someone else. And it could be just like you are earning set of tokens for running the node and from the attention that you are posting on social media, and then using those same tokens to run the node again by staking and earning more money. So deterministic actions, transformations and indexing are a couple of those, like generating thumbnails, and you have big pictures, you want to generate smaller thumbnails. That is all very compute intensive. So talking in terms of machine learning people who do machine learning, artificial intelligence, when they want to scale down their data and all of those things. So these are some of the things that they can utilize our network to do at a very close to zero costs. Time-based things, retrieval and data gathering, you can roll back down to time and figure out whether this thing was done by someone or not. So these are some of these things. Coming up next, I promise you this is like my second last or third last slide or something like that. So I won't bore you guys much, but give me a second. Sorry.
Us by us.
What?
Us by us. Us.
I didn't get you. You need to be louder.
Us.
Okay. So how vast is it actually? You might be thinking, since the start, I have been just talking about data, compute, Web3, decentralization, distributed systems, and everything. Mind me guys, for any of you guys using your phones right now, you might miss this crazy thing that is happening in the space right now. I might have shared it with a couple of my friends sitting here to vouch me a couple of days back. But for any of you guys using your phones or talking to anyone, you are going to miss it. There is a new term in the ecosystem right now. How many of you guys know that AI is booming and Web3 is in a bear market right now? Everyone does. Everyone does agree to it, right? So there is a new term coined which is federated learning. Now, most of you guys would not be knowing about it. So let me just give you a quick intro to it and then we'll quickly go through what are the benefits of it. The quick intro to it is, think of like the major sectors where federated learning could be utilized as healthcare sector, where data privacy is a very big concern. So, first point, we want to improvise the global healthcare sector on a global scale. True. How many of you guys agree to it? Hands quick high in the air, please. Once. We need to improvise the global healthcare sector. Second, will Indian government ever agree or would they want to give their Indian user healthcare data to the United States, or whether they'll agree to give it back to us? No one will do, right? They'll never do. So this is a huge barrier into how things could be utilized, or even dude, like hospitals won't share that data. Don't give a fuck about governments, hospitals won't share that data. So this is like, distributed LLMs and all of those things where you can train a certain model on thousands and tens and thousands of parameters and then get them to reply back to you on smaller, very small parameters. So this is like, a conjunction where AI, machine learning comes down to interact with us, Web3 and the data layer. So this is where like, this is what they are three different AI models that are running on three different devices globally and locally, and all of these three different models train on three different data sets. But what is the idea? The idea is all of these models are synced to a central place. So the data never gets there, but only the models are getting there. When models are getting there, we are certainly improvising on a lot of things. So I'm like, this is a very promising thing if you guys want to go and dig deeper into it. So again, the term federated learning has come very recently, but there have been research projects that have been doing this shit before Web3 and decentralization would have ever existed. There's a project called SETI at Home, and then they have this bionic thing that has been existed since 30 years when we were not even born. So, okay, let us quickly get back and discuss their advantages. We get data diversity, as I already discussed to you guys an example that the data diversity is there. Then data transfer, because the data stays locally, so the data does not need to be transferred here and there, and hence we get an advantage over latency, compute, and a lot of other things. And then efficient updates, when you are getting synced models, what else do you need, guys? Again, and then the next point is privacy preservation, because getting users the control of their data. Coming to regulatory compliance, because regulatory compliances are a big concern for the governments, how they govern the entire industry that is working on it. Lower server costs and a couple of other things. So coming up next, these are a couple of examples. New York Times tackling AI AI content scraping and everything, because you know what, I mentioned about it earlier. So coming to Twitter, let's take the Twitter example for now. I think then you would be able to relate to what is New York Times example and the other examples that I was talking. So talking about this thing, Elon Musk recently imposed a rate limit, 300 tweets, 600 tweets a day, and a lot of people were struggling with it, right? So even people who were wanting to scroll more, 5 hours on Twitter, they can't do it. So that was mostly just to prevent a lot of other things, but that is their engineering standpoint, none of mine. But coming to the next thing, what you could do is, if Twitter is allowing the same thing that I discussed before, secret injection, you can write a task that asks for Twitter credentials, roll it down to 1,000 users, just 1,000 users, and then those 1,000 users are getting 300 tweets each for you for free. That is the advantage that you get. So, like, you know, these are a couple of other use cases that I'm talking about that you can do with our network and everything. Coming up next, we have this grants program, which is a $1 million US grants program, and we have partnered with Builders Tribe to roll out this program. And so, like, you know, if any of you guys are building or, like, you know, want to work with us, happy to get you guys into the program and start building and rolling. There is a quick flywheel of how we have been working. We are a short team of 30 people, and out of those 30 people, 25 people are devs with a very short spend on marketing. We have literally just, these are, like, you know, the numbers that we are having from just, like, you know, global. We just attend these couple of conferences, and this is all of that organic thing that we have reached. We have got 30 million plus views on the network from the attention tracking thing, which return got the community to earn 300k plus of koi tokens. And while doing all of this engagement with the network, we got people to do node signups for us, which is, the updated number is 60,000 for now. This is from one of my old slides, and I did not find a link to edit it. So the number is still 45 here, but the number is 60k right now. And you guys can still try to run a node on your devices. Head over to the link koi.network/node, and you can run it on your own devices. So that's all, guys, from my side. Thank you for your attention. And there are a couple of my Twitter and my company's Twitter handles. If you guys want to follow or anything, open for any questions that you guys might have, and then we can wrap this up. Any questions, guys? Anyone? Okay, I think we are good to wrap this up. If anyone has any questions, I'll be around, so you can find me and catch up, and, like, you know, we can chat about it. Cool. Thank you, guys. Bye.
Thank you so much, Sandeep.